So we'll wait for a few more minutes and then begin. Okay, I think enough people are here. Yeah, we'll just start with the session. Yeah, the first question. I suppose everyone knows the drill. Hi. Sorry, I wasn't aware that my mic was muted. So, anyways, yeah, cool. Everyone knows the drill. So, people who are new to my session, I'll just display a question and there would be a few objective answers. I mean, the question would be objective, so you'll have to pick one of the answers and write it down in the chat box. For the initial part of the question, I would prefer you only stick to the chat box. Later on, after the question, after people have answered, or like a number of people have answered, then we can discuss if we want. That is. All right. So there are 6 and 10 people. All right. And I've got like 4 answers. Rest of them are not trying to attempt. What happened? Sorry, my mistake. Yeah, so it's a straightforward definition. I don't think we need to discuss, but the individual's production of offspring over a lifetime is actually reproductive success. And C and D aren't the right answer. But I am not sure why nobody answered B. Wow. Okay. Anyways, next is this. So B, B, D, D, A. Nobody else? So yeah, so the number of offspring that go on to survive and reproduce themselves is fitness. Fitness is, it's important to know fitness, the definition of it, because a lot of evolutionary theories and all are dependent on this particular term, fitness. They keep on saying the maximum survival of the fittest. What is fittest? Like it's not strongest. It's not. You understand what I'm saying? So fittest actually means this definition, and not the strongest, the highest jumping, or the highest flyer, or whatever. Yes or no? Thank you. People there?
Yes, we are listening.
I'm listening, sir. Listening, sir.
All right.
Yes, sir. Very good.
Sure. Thank you. So yeah, so that's why it's to remember this term is actually a little more important. Anyways, I'll move on to the next question. 3B B C C C A D. So yeah, parity is number of episodes of reproduction that and
Fecundity, no, sir. Fecundity is the successful, and how many times the episode of reproduction happens. Once if it happens, it's called as clutch size, but the multiple clutch sizes are called fecundity, no, sir. Is it parity? I'm a bit confused, sir.
So parity, no, multiple clutch size. Fecundity would depend between time periods or something. So fecundity, fertility, yeah. Parity
Number of
is within.
offsprings per episode.
Sorry.
The fecundity would be number of offspring produced per reproductive episode.
Yeah, and this is the number of episodes.
Fecundity and clutch size are the same, and only difference is fecundity applies to more than just birds, right, sir?
Just look over the next question.
It's something like number of depending on the survival rate, fecundity and clutch size would be.
Question 4.
Sorry, sir, I need to read more. I'm getting confused with clarity, parity, and fecundity.
Okay, so suppose a bird returns from migration and starts breeding. Okay, so it has got one season. Okay, I mean till now you're here with me. I mean till now you understand. It's got one season to breed and then return back to its wherever. I mean wherever it is migrating to. Okay, so that one season would be say from December to February or December to March. So then, what birds can do is come early in December, start breeding. Probably it takes like a month for a lot of passerines to finish breeding and till the chicks fledge out. Like 15 days of sit brooding the egg and 15 days of feeding the chicks and fledging. And then they're free again to breed. Okay, so they have 2 more months. So it can happen that the next 1 month or after 15 days, next 1 month, it can start a cycle of breeding again in the same nest. Do you understand, Lakshmi?
Yes, sir, I got it, sir.
Yeah. So that is parity. So basically, it had several reproductive episodes within that season. So that's the parity of the bird. So it becomes 2, or even like within reproductive episodes within a lifetime can also be called as parity. So how many reproductive episodes did it have? Now, when you talk about fecundity, it's not the reproductive episode; it's the number of eggs or the number of chicks or number of offspring. So, I mean, fecundity can be a term given to mammals as well. So that would be number of offspring, and that is per reproductive episode. So, or number of eggs laid over a specific interval of time. So, which do you think is per reproductive episode? Fecundity or clutch size?
Clutch size, because it's per
For one episode, yeah.
for one episode.
Okay, and fecundity would become like for a specific time interval. So it could also be like one season where the parity of the bird was just 1. That would mean that fecundity and clutch size are
Same, both same.
that's it.
I
Got it.
I was thinking from the lecture that clutch size is related to the eggs versus fecundity is related to the number of chicks produced. So if there is a lesser survival rate, the fecundity would be less than the clutch size, right?
Um, there's also something called fertility.
But okay,
So fertility is basically the number of eggs that
hatch takes.
the bird can actually produce, or something like that. But yeah, I mean it's there in the lecture. I mean I've taken these definitions exactly from the lecture, so just check, Sachin. Yeah.
Okay.
All right. I mean these words are verbatim, so I didn't change anything over here. So the answer is clutch size and fecundity both.
Sir, I didn't quite get the whole question. What is it meant by it survive between 2 points in time?
So suppose it's 2020 and 2012. Okay, 2021. Within a year, there were like 10, okay, 100 individuals that have hatched and that have fledged, uh, or it could also be 100 individuals that are hatched and fledged, or just hatched, I suppose. So out of that 100, there were 50 that died, and sorry, 60 that died and 40 survived. So that would be 4 by 10, that's 0.4 is the survival from 2020 to 2021. Yeah.
Okay, sir.
Yeah. So yeah, that's actually survival. That was not a big. Okay. A D B B B C. Okay, what do people understand from semiparous species?
They die after the reproduction. That's
They
what
are
I remember.
short-lived. They are short-lived, and hence they produce a lot of offsprings, and then they die. It's like as if they come to adulthood only to reproduce, and then they die.
Okay.
So
Like cicadas,
they will
monarch
have many
butterflies, and
offsprings.
phantom.
They will have a lot of offsprings. Like let's say whatever it will be too much of offsprings, so that the survival rate increases.
Yeah. Can people give me an example of
This
a semiparous species?
Spiders?
Cicadas, sir. Periodical cicadas.
Black widow?
Salmon. Monarch.
Okay. So, yeah.
Salmon?
Okay. So,
Cicadas.
all right. So, do you think, I mean, since they are producing so many offsprings, do you think it's possible for them to produce large offsprings?
No.
No, that's why the energy is gone. Because of that, they give in a short burst of reproduction, they give a lot of offsprings.
So, okay.
Okay.
Yeah. So it's not possible for, I mean, if you are producing a lot of offspring, then it's possible only for you to produce like smaller offsprings, because otherwise a lot of, yeah, I mean, there has to be a trade-off somewhere. I mean, I hope people understand what trade-off is. Yeah, Govind, go on.
In another way to answer this question, option B was the only one that didn't agree with the other options. So, an organism could usually short-lived dies after reproduction and single bout would all the other options come together except for B, sir.
Right, Govind.
Okay.
Sir, in this megapod, they are least invested in parenting, no, sir. So they don't come under alteration. I'm a bit confused.
Yeah, what's the what's the confusion? Ah, yeah.
They might not come in both the types of precocious or altricious, no, sir, because they are the least invested parenting. In both the precocial and altricial, some amount of investment is there. Altricial, higher investment of parenting and energy, and in altricial one, lower investment of parenting energy. But megapods, they are a different class apart, no, sir. Hardly next to nothing. They don't actually do any kind of parenting, no.
Yeah, but what do you mean by precocial?
A longer incubation period, no, sir. For that, they have to sit on the eggs, right?
But I'm talking about precocial chicks. Yes, Govind, please go ahead.
Sir, the difference between altricial and precocial can be viewed as which stage to exist more, either the eggs or the chicks. Just
Yeah, exactly. So I'm talking about the chicks right now.
yeah, as when it comes to chicks, precocial chicks, since the egg has already been, since a lot of energy has already been invested in the egg, the chicks are a lot more independent and capable of fending for themselves, especially for megapods. Megapods, they lay a single very large egg and build use creative and resourceful means as a way of incubating them. Like like the maleo bird from Indonesia, which lays eggs near volcanic soil to incubate them, or lays eggs, or birds that lay eggs in rotting vegetation.
Vegetation, yeah. Yeah, so I, Lakshmi, I don't think it's based on the amount of care. I mean, yeah, there is one part to it, and obviously, nature is not exactly binary all the time. But altricial chicks demand parental investment, and out of all the four, which do you think gives, or which species can actually or does provide parental investment?
I would expect water hen to be precocial. Um,
Yeah, water hen is precocial, right?
yeah, but I'm not sure whether puffin would be in the altricial chicks or not. I'm not sure.
So basically, think of it this way: if the chicks can hatch out and come and feed on their own, then they're
Right,
precocial. If they can't feed on their own, then they're altricial.
right.
Puffins, puffins, the parents take a lot of food for the chicks back to, I mean, from the seed back to the this thing. So definitely, the parents are feeding the chicks. The chicks don't feed for themselves,
Okay.
at least till not till they fledge. So that would mean the water hen has chicks that can feed for themselves. Parents are not exactly, they just roam around with the parents, but they don't exactly, parents don't exactly feed the chicks. Peafowl, similar. Megapod, the parents are not even invested at all. I mean, not at all invested. So chicks have to fend for themselves. That's like the extreme case of precaution. But puffins happen to be altricial in that way. Yeah?
Sir, puffins have very large beaks to carry extra fish, right, sir? It's
Yeah.
a defining feature of them.
Yeah. I don't know if that's to carry extra fish. Why would that large bill evolve is something I have not studied. Probably you can look it up. But yeah, they do carry the fish back to the nest to feed their chicks, is what I understand.
I saw it in a documentary once, sir.
Yeah. Yeah, that's, I also saw this documentary. Yeah. All right, so let's see what the answer is. Puffins. Silly question, but yeah.
Sir,
Yeah.
is this question ideal ideal questions at like ideal time? Because there are times when the prey is insufficient and there are times when the prey is bountiful. Does this question take into account ideally how it should be, or?
No, it's just a part of optimal foraging theory. Oops, I gave up the gave up the answer. But it's just a part of it. There are several other theories within this theory, or hypothesis, no, theories, I suppose. Yeah. So it's not at all ideal. I mean, things keep changing. Like there are over studies on this. So
Yeah, that's what. No, I asked the question ambit. The question takes into account ideally or ideal hypothesis, or like that's what I wanted to know.
what do you mean by ideal? I didn't understand though.
See, ideal means I said ideal means a stable environment and good availability of food. but in nature it doesn't happen. So, during the during there are some part of season where you get bountiful of prey and everything, and there are part of seasons where it's scarce. So I just ask, is it
Oh,
does
like
it take
that.
into account
No,
idealness or just
Lakshmi, no, the thing is, if everything is ideal, like you're getting a lot of food available, then why even bother with this thing? You'll just eat whatever is in front of you, right? Like in our case, I suppose. We want dosa, we get dosa. We don't think about going out and, yeah, basically. I mean, ours is an ideal case. I
No,
mean,
that's what, sir. That's the question which actually the last part, with the lower profitability should be rejected. No organism actually rejects prey, no, sir.
no, no, they do.
Do?
Yes.
Okay. Can I have some examples or something? Anything out of your mind or something? Or where can I look it up, sir?
Like if so I mean have you not like elephant sitting in front of a big buffalo? So, I mean you might have seen it in a lot of National Geographic photo. There are, sorry, not elephants, there are lions, a troop of lions and big buffaloes in front of them, and they decide not to attack the buffalo because they know, like big buffaloes, there would be like 10 lions have to take on a buffalo, just single buffalo, to bring it down, right? So the handling time for a buffalo is really really great. They don't take the risk, and the risk is also not just the handling time, it's the risk to the lions as well. I mean, they might get hurt because of the big buffalo. So they would rather prefer to go for a smaller organism, as long as the organism, I mean, also, I mean, so yeah, then again there's this variable that comes over there, is if the organism is easily catchable. So again, the handling time. So if the organism has to be chased and caught, and the organism happens to be something like a very agile deer or something, or a, yeah, so then that would again mean the handling time increases. And yeah, so
Okay, so now if the predator goes behind a vulnerable prey, the healthy preys are all being rejected. In that sense, you are saying, sir?
no, 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 no. So here there are two things over here. There's an energy content. Okay, so that would mean the size of the animal. Actually, you'll understand more in the following question, but size of the animal. So a lion wouldn't bother with a rat or a mice, right? Because the size of the animal is too small, and for a lion to hunt a rat would be like a waste of so much energy to get this much of meat, right? You understand that part, right?
Yeah, I understand, sir.
Yeah. So, and for a lion to hunt down an elephant or a really big buffalo would be really difficult, because the number of individuals required to bring down a buffalo or an elephant would be really high, as well as there's a risk that the lions or the individuals hunting the buffalo or the elephant is taking, that they might get fatally injured. And in nature, getting fatally injured is like death, like sure shot death. There is no other way. So they will optimize both these things and come to I mean, then there are like certain preys that are preferred by lion, because the energy content is high enough for them to survive, and the handling time is also low enough. So basically, lions are ambush predators, so they prefer, yeah. But ambush predation doesn't work on buffaloes anyways. I mean, so
Yeah, I got it, sir.
yeah.
I got that.
So there has to be a trade-off. I mean, people understand what trade-off is, right? I mean, there has to be a give and take. You cannot have everything. You'll have to give. You have to give up on certain things as well. So trade-off can be in anything, like plants, for example, like we said, semilparous. So there has to be a trade-off between the number of offsprings and the size of the offspring. You cannot have both the high number of offsprings and big offsprings at the same time. You'll have to have some trade-off there. You cannot have a high energy content of prey as well as a low handling time. So E by H is like basically, so again there's a trade-off over there. So trade-off is what, I mean, cost benefit analysis, more or less, yeah. how much is the cost and how much is the benefit that you're getting. Yes, Govind, please go ahead.
You said that it's not possible for a situation where there's a high amount of energy for a very low amount of resistance, right?
Sorry, so Govind, why aren't you not very clear? I mean, yeah, go ahead, please. Sorry again. If you want to write it in the chat box, it would be much easier for me to understand.
You mentioned that it's not possible for a situation for a high amount of food and low amount of temperature in nature.
A high amount of, yeah, and low amount of handling time, yes.
What about, say, in the case of lions and buffaloes, say the buffalo in question is injured or sick and it's not in a position to defend itself properly. In such a case, the two lions and the handling time would be significantly lower and the food and the energy gain would be higher since the amount of effort it would also be low, right, sir?
Yeah. That is true. I mean, but we are not talking about individual cases, right? We are talking about the, we're talking about like a normal. I mean, what is it called? Normal curve. We're talking about a population over here, where obviously there would be like extremes. There would be exceptions all the time, but yeah, that doesn't actually get accommodated into the entire what's happening with the entire population. Yeah.
Then what about snakes, sir? Snakes, venomous snakes especially can often hunt down their prey with less amount of risk thanks to their.
Yeah, but in case of snakes, there is no chasing, right? Is there a chasing in case of snakes? Do snakes chase animal and kill them? No, I don't think so. There is an ambush. The snakes see the animal. There's an ambush. I mean, the animal doesn't see the prey for a really long time, and then suddenly the snake attacks the animal and injects the venom, and then there is the entire handling time. There's a lot of handling time till the animal dies, and then it has to ingest the animal. Okay, but yeah, I mean, obviously this is a theory, and it doesn't hold true for a lot of examples. I mean, you might come across a lot. I mean, if you get into this whole and I mean, optimal foraging theory. If you get into this, you will see a lot of examples that it doesn't hold true all the time. But this is like one of the hypotheses that is the. So basically, it takes care into
Do you
the
give an example?
where it's not holding true.
Yes, an example
Yeah,
where the optimal
I wish I'd
foraging
actually studied this. I mean, for me, it's just one theory that I studied in my college, and I haven't. I mean, I haven't studied like for what I study as my PhD is something else. This is something that I know because I studied in my college. So I wouldn't know the example. I can't think of it, but I can get back to you once I have to. I would have to read up on this. Yeah, Govind, you sure of that? I mean, I'll get back to
Okay,
you
sure.
once I read. Yeah, I'll have to read up on this. I mean, I can't just come up with an example like that. It's not something that I actually studied. Anyway, the answer is optimal foraging theory. Everything else was bullshit. I don't know. I mean, yeah, it was something that I came up with. Oh, okay, next question. Actually, you know who studied optimal theory? I mean, I think Moshimi has done Yeah, she has studied optimal
Yes,
foraging
sir.
theory. So
Yes, sir.
yeah,
She has
you
done,
should
sir.
ask this question to her. I mean, you know why there are like 12 people teaching you each subject, because all of them have gotten expertise in certain other things. As TS, we are barely there. So yeah, I mean, the right person to ask that question, Govind, would be Moshimi and not me.
Sorry to be off topic. Can I know what is your field, sir? What you did?
I
I mean,
am I'm studying distribution of birds in Shola Sky Island.
okay.
So
V.V. Robin, sir?
yes,
Professor V.V. Robin.
yeah,
Okay.
and invasive species like in invasive timber stands. So that's what I am studying, and yeah.
Sir, here nest predation equates to brood parasitism?
No.
No. Okay.
Uh, Nest predation is. Uh, what do you mean? What do you understand from brood parasitism, Lakshmi?
Where the parent, which lays egg, the female parent or whatever, they avoid investing energy in raising the kids by offshoring the eggs to the other parent, the other nest. Where they don't have their own nest and they lay egg on a forced nest, so that their expenditure of parenting energy is less or nil.
Okay, okay.
They don't want to.
Oh, okay, okay. No, no, no. That is not nest predation. That is actually brood parasitism. Nest predation is basically predation upon a nest. Like the chicks being eaten, the eggs being eaten. That is nest predation. Sorry, I wasn't clear. I thought, yeah, I thought it's like a term that people will, yeah, very well known term. So it is predation upon a nest. So there are animals like rats and what's that animal called?
Snakes.
Civet cats and yeah,
Snakes.
snakes. Yes,
Yeah, a monkey is eating eggs of the
yeah.
birds.
That
Okay.
is nest predation, and no, brood parasitism is not a form of nest predation. Unless the while the mother is brood parasitizing, she eats the eggs and doesn't throw it out of the. Then it becomes nest predation as well. So then that's the case. That's an example of both.
So could you, do birds also engage in both?
Sorry, what? Do birds?
Are there birds which engage in both predation and parasitism?
Yeah. I think cuckoos do that. I have seen videos where cuckoos are eating the eggs up. The mother cuckoo, and yeah, but there are birds that I know who do brood predation but not brood parasitism, like the hornbills. They eat eggs, but they don't brood parasitize. I mean, most brood.
Aren't
Sorry.
hornbills frugivores?
Oh, not all. No. That's a misconception people usually have. They are frugivores, but they are not the obligate frugivores. There are hornbills are known to eat a lot of things apart from. So we have. I think I have a paper. Yeah, I have a paper on. I have a short note somewhere where we saw um, Oriental.
Sachin ji, can you switch off the mic, Sachin ji?
Yeah, sorry.
Yeah, so where we saw a hornbill in northwest Bengal. We were in one of the forests over there, Chapramari, where we saw it feeding on a flame-throated bulbul. Yeah, one of the bulbuls over there. So the chicks of the bulbuls. So yeah, they are not frugivores. I mean, of course they eat fruit, but they are not obligate frugivores. That's just not. I mean, it's fruit is not the only part of the diet. They eat. I mean, if you Google up hornbill, you'll see that they eat a lot of other things apart from fruit, like the eggs.
Also, ground hornbills eat snakes.
Sorry.
Also, the ground hornbill eats snakes. in Africa.
Ground hornbill of Africa. What about it?
Well, I've heard they specialize in eating snakes.
No, I don't know about that. But yeah, I mean, so that was one case where we recorded it in the photo, and then we also had like some camera traps in. So we had like these nest boxes. So nest boxes are these artificial nests that are placed in the forest or wherever, and the birds come and breed in them. So we had nest boxes across the forest, and there was this white rum shama that had come and started breeding in it, and we had put like camera traps in front of the nest box so that we know if the nest. Oh, but actually we were doing a lot of things with the camera trap. We were trying to see how the parental provisioning is happening, who comes, the male or the female, and also what kind of predation is happening if it's happening. So we had like one of the photos where it was a hornbill, the same hornbill that's found in those region, predating upon the white drum shama chicks. So that was one of the photos that we got in the camera trap. So yeah. Yeah, I'll come up with the answer then. So nest predation is a process that favor coexistence of bird species that partition resources where nest sites are resources. So what would this entail? So it's a very long-winded theory, but you'll understand this once you get to know the next question. So if you just read this paper, Martin, I forgot the name, Thomas Martin, 1988. You can read upon this paper. He talks about how nest predation and predators, like how it goes hand in hand, and it can create like a partitioning of resources amongst the bird. So basically, okay, let's just take this answer and then go on to the next question, and you'll probably understand a little more. Yeah.
Sorry, sir, I didn't understand the last part. What do you mean by learning search images?
Yeah, me too.
So we think. I mean,
Learning search images means learning cues, visible cues.
yes. What you are thinking is the right
Okay,
direction.
okay. Sir, doesn't B is antithesis of it, like if it is able to have this high efficiency of prey specialization, similar species they might get confused, no sir?
Yeah, exactly. I mean, high search efficiency by specializing on prey types. So similar looking species,
Yeah,
they might get, yeah, they
they
might
get
get.
confused and get predated more.
Yeah, so B is definitely true. Then what can happen? Like evolutionary, think of it. So evolutionary, it might happen that different species of the same region um partition the resources, and resources over here is the nesting sites. So it might happen that some of the birds might nest in the ground, while some of the birds might nest in the middle story, some in the upper story, some in the understory. So that way the predators, predators have also have search images, so and they have this learned instinct or learned behavior kind of a thing. So if they find that the nests are almost always on the ground, then they will then they'll just learn it up, and then it will be easier for the predator to find the next egg, next nest. So that's why the predators can also partition where the birds are nesting in the vegetation strata. So different strata of vegetation.
Sir,
Yeah.
I'm sorry, sir, I didn't get what you were saying. But then the last part, how do the predators partition the different data?
Okay. Um, okay. So there are some five species in a locality. This is I'm not talking about the recent time. I'm talking about like in evolutionary time period. So there are like five species in a locality, and all of them have learned to nest on the ground. Okay, and the predator has a search image uh, of of where to find the nest. So, what do you think would happen to all the five nests now, of different species, but they're all on the ground? What would happen?
All will be
It
in.
all gets split apart.
Yeah. So now there are a few species that learned that okay, let's not. So you have to. Okay, I am saying it like it's thinking for itself, but you have to take it with a pinch of salt. So let's imagine that some of the birds uh, mistakenly or for some other reason started building a few nest a few meters above the ground. So say two of these birds started building nests a few meters above the ground. The predator still has the search image. Now how many will get predated?
The remaining.
Three.
The remaining three.
Remaining three. Suppose now one of them remains on the ground. The second of them remains 2 meter above the ground. The third remains 5 meter above the ground, and the fourth is in the canopy. The fourth and fifth are in the canopy. Okay. Now one of the predators, instead of the ground, it finds the nest in 2 meter height. So it forms a search image for that, right?
Does it mean that it has
Like the predator is also evolving along with prey.
Yes, yes, yes. So, so it doesn't matter.
Does that mean that the nest which is in the ground will also be predated, and also the nest in the second 2 meters up, that will also be predated? No?
No,
So because
so now,
already they have search cues for the ground, right?
yeah, yeah. But predators are not born with search cues, right? So they have to realize, or they have to learn the search cues. But the nest on the ground is getting less and less. So it's not easy to find a nest on the ground anymore. Like initially there were five nests, so it was easy. Like you could stumble upon one, and then you can learn the search image, and you can get a search image, and then you can find all the five. But now there's only one nest. The probability of finding a nest on the ground is reduced. So the predators are also, these search images are not born to them, and it doesn't come.
Okay.
They
So
have.
it's like catch up. The predators always catch up with the prey. Okay.
Yes, yes. So now there's a resource distribution happening because of the predator. It's one of the theories. Okay, it doesn't always happen like that, but one of the theories. So, but you understand what the paper is trying to say, right? What this line is trying to say.
so here the predator is actually trying to identify the a specific type of species or their nest, right?
Yeah, specific type of species or specific kind of species.
Okay.
But not specific species. That's basically. That can also happen, but that's basically giving too much credit to the predator's search image. They'll only attack like a specific species.
So then that would mean that a particular group of species uh, will only be target of that predation. So others may not worry at even if there are suppose five types of species who are making nest on the ground, will they all be targeted by the predator? Because it might just have data, or they might understand that I might have to target type 1 and 2 species. So other three might just be safe. Is it the understanding from that conclusion from that?
No, so the more the predator finds nest on the ground, the more it becomes more aware that there are nests on the ground. So more it starts searching. So there's this other line that also says you must read that paper. There's this other line also says that if the probability of finding nest or on the ground increases, the predator is more and more adamant on finding nest only on the ground. So if the birds can somehow partition these nests, the vegetation strata, and make nest in different strata, the probability of finding nest on the ground reduces comparatively, and the predators, the search image gets confused. Confused, as well as it doesn't form properly or something like that. You understand what I'm trying to say, right?
Yeah, I understood that part. What I was coming to is whether the predator are trying to target some particular group of species and will actually all of, I mean, if, as I
It
was
also
thinking, I
depends on
mean,
what kind of predator we're talking about.
hmm,
Yeah,
okay.
if it's a ground predator, then probably the major food item, or the major nest or major kind of nest that they would prefer would be a ground nest. But if it's like a mesocarnivore that can also go up and down the tree a little bit, then that would mean that the 2 meter, that would mean that it can actually target a lot of strata of vegetation. Say for example, a marten, for example, uh, attack a lot of strata, but on the other hand, something like a dog or a canid, any species of canid which cannot climb a tree would actually depend only on the nest that are found on the ground, which is actually true for dogs as well. They do hunt, and they do look for nest on the ground, so they do learn it very fast.
What about
Okay.
another bird?
Uh,
Would they be
how,
able to
does this
all
yeah, does this theory apply to omnivorous birds, or the birds, generalist birds, which doesn't are prey specialist? Does this theory apply to that on them also?
Sorry, I didn't understand.
Does this theory hold goods to those birds or those organisms which are not specialists? They are generalist in the sense they are okay with whatever prey they get. Does this hold good with that? With those are species?
I don't think so. If they're okay with whatever they get, their energy, they can acquire energy with little searching. Of course they do searching, but general species thrive because they can adapt to anything. So yeah, specialist species generally get affected more because the prey are special. They have special preys, kind of a thing. Yeah, go ahead.
Sir, I just had a doubt regarding trade-offs and this recent question. What is the disadvantage to being omnivorous? I mean, you mentioned that everything has a trade-off in nature, let's go free lunch. So there must be a disadvantage to being omnivorous, sir, but I can't find the disadvantage.
There must be a disadvantage to being an omnivorous.
Right, right, sir. Since they're able to find food much easier than either specifically herbivorous or carnivorous species, then that this advantage must come with its own disadvantage, right, sir?
Oh, so you're saying evolutionary, there must be a advantage to being an omnivorous because they can find food everywhere.
Well, yes, that's the advantage, right, sir? So this naturally must come with a disadvantage.
Yeah, but okay, name one omnivore and name the food that is like available everywhere.
Bear,
Bears. Okay, what do the bears eat? Like vegetarian part?
they eat berries, fruits, sometimes grass.
Yeah, and is it available every time of the year? Are they available every time of the year?
Um, sure.
No. And what do the herbivores eat?
They eat similar
No,
pieces of vegetation.
not berries, not fruits. They eat what? Grass and leaves, right?
Yes, sir.
And they also have special stomach to digest grass and leaves because that's not a usual food item, but people, I mean, the animals eat it.
Sir, going by what you said, you only said a few seconds ago that those food item or the doesn't available not all through the year, right? When it comes to bear, when it eats the grasses or something, those grasses are not available the whole year. The berries will not be available the whole year. But there are organisms which are dependent on those berries for the whole year. Isn't it a paradoxical, sir?
No, it's not. Do I mean it's not exactly. So that's why it's important to have different species in a forest which can produce berries at different times of the year.
Okay, sir, I got it. I got
Yeah.
it.
Why do you think hornbills are so? I mean, yeah, they are facultative nest predators, but the major portion of food that they eat are fruits and figs and berries. So why do you think it's? Uh, why do you think because of the reducing forest, the hornbills are the ones that are affected the most?
Because of deforestation, these berries bearing trees are lessening in number, and that's why they are shrinking their food source is shrinking. That's
Yeah,
why.
food sources is shrinking, and that's why they have to travel longer distances to find more berries.
So I have one question here. So whether the nest predation has evolved as a reduction in the number of resources, or whether that has been a trade of the carnivore or whatever.
I don't know. I mean, that's a very that's a good question, but that's something that out of my gambit. Like, why did it evolve and everything? But I mean, it's worth actually looking into. Probably you can look into it and come back with answers the next time. But
Okay.
yeah, it's not. I mean, it's not a very easy question to answer. You know that, Sachin, right?
Yeah. Thanks. So, by the way, just a curiosity, did you refer to this nest predation and nest site selection of western thrushes or something? Is that the paper?
It's the paper number. The
West.
name is given Martin 1988. It's Thomas
Yeah, but
Martin.
Martin 98. I searched for that and I
Thomas Martin. Thomas Martin.
correct.
Just let me
The
just.
one that I got just now was written by Thomas Martin and just a minute. James Roper. Is it correct? This is a
No,
1988 paper.
no, no,
First.
no, no, no.
No? Okay.
Let me see. Thomas E. Martin on the advantage of being different nest predation and coexistence of bird species.
Okay, I'll search again.
Let me just copy it and paste it over here.
Just type the name in the chat box. I'll search that.
Sorry, it's a old PDF, so everything is like this. But you understand.
Got it. Thanks.
Yeah. Anyways, I'll move on with the answer for this is both. B comes first. I mean, anything can come first, but basically both can happen over here.
Sir, can we say crows are a good example for this question? Crows and ravens.
Why do you think so?
If I have understood the question correctly, uh, then my choice of answer is also correct because this is clearly demonstrated in crows. I haven't seen ravens, but I have seen crows. So it's very common in crows, wherein one crow
I think ravens are
finds a
solid.
carrion.
Ravens are
And
solitary
then,
animal. But yeah, you are
uh,
right. You are right, Lakshmi. I did a very small study on it once when I was in Pondicherry University.
So yeah, one crow gets a carrion, and it goes back to the roosting site or the place where they are meeting, and they have this cues. They touch beak to beak or something. I have not exactly gone deep into it, but from my terrace, what I could see, they touch beak to beak and they preen each other, and then suddenly the second bird flies off, and it also gets a part of that carrion, and slowly in a matter of 5 to 10 minutes there's this whole lot of crows coming into the carrion and having that food, wherein only one crow finds it out. So I think my choice of answer is the correct one because that's what actually happens there.
Okay.
Sir,
Yeah.
I didn't quite get the graph. Could you explain the graph alone?
Okay. So there are experiments done on couple birds, like two birds together, dyads, and one knows where the food is, and the other doesn't know where the food is. No, basically, if you look at the y-axis, it's the time proportion of joint flight. Like, how long does it take for them to fly off together? And the x-axis is basically the couple birds. Two of them are unaware of the food being present. The second is two uninformed, but food is sorry. So the couple birds. The experiment is where two of the birds are uninformed, two of the birds are uninformed, but in one the food is absent, and the other the food is present. The third is both one is informed, the other is uninformed, and the fourth is two of them are informed. When we talk about informed, you understand what it is, right?
Asking
They are informed of.
Okay, so I'll tell you what. So the so basically the answer is, I'll just tell the answer first. Okay. So the answer is information center hypothesis. What is information center? Can anyone explain that to me? What is the hypothesis basically?
There was an experiment done wherein a carrion was colored blue color, and it was put near a place where it was known place for roasting of crows, or I'm not sure, crows or ravens. And then what happened once they found a pellet of one meat which was blue in color near the tree roots, below of the tree, and then slowly in a matter of I guess over a matter of time, there was much more pellets of that meat below the tree where this roosting was happening.
So what does
And
that
they
mean?
came
Yeah.
yeah, they come to conclusion that this one bird which found out the food, it went back and it relayed the message to the other birds, and slowly one by one they came and they had the food. That's what the hypothesis. That was the experiment.
So yeah, information center hypothesis basically, yeah, what you said is right. There is an informant bird, and a bird that is informed about where the food is present, and there are other uninformed birds usually. And now what happens? Like, it all depends on the species basically. Does the informed bird come back, and how do the other birds get to know, like, that the informed bird knows that the food is present somewhere? So that is all something that we don't need to trouble with right now. But what is information center hypothesis is that there is a center where all the birds come in, and some birds somehow know that the other birds know where the food is, and then they follow the bird with the knowledge about the food. That's what the information center hypothesis mean. And the next question might actually clear it much better. Yeah.
Can we go back to the last slide? I have a question here. So, the reduction in the last two informed thing, does it mean that they communicate and in a way or whatever, and they understand that both have the information about the food or same type food, I mean, resource, or different types of, so they don't need to stay together for longer time? Is that what the conclusion will be?
Yeah.
Sir, so the conclusion in the graph is that when one bird is informed and the other is uninformed, the bird that is uninformed will follow the bird that is informed a lot more, and then they flock together a lot more, right, sir?
Yeah. Wait, I'm just trying to find where
This is for a same species thing. Experiment was for same species.
yeah,
or,
it's an
across?
intra-species. Yeah. It's for a vulture, I think. I can give. You can check the paper, Harold 2017 vulture.
Zahavi's paper or?
No, not Zahavi's, Harold. It's written below where I got the. I have misplaced the paper, but I can wait. I can look into it. Huh. Yeah. Yeah.
Thank you.
Sir,
Yeah.
sorry to interrupt, but the paper headlines, I mean, the topic of the paper which you have given along with the question, the first word itself is actually antithesis with the first option, no, sir. But actually, the answers are all fitting together. So quite contrasting.
What is antithesis? Sorry.
I mean, like, see, falsifiability, it means that the information can also be false,
Yeah.
right?
No. That's not.
Level of
Falsifiability is basically they're trying to prove if information center hypothesis fits well or not. That's all. The hypothesis falsifiability, not the information.
Okay.
I mean, yeah. Falsifiability of the hypothesis. That's all. So yeah, so there are like certain mechanisms with which the information center hypothesis. I mean, I have just mentioned 3. There are 8 mechanisms. If you want, you can read the paper as well. But basically, in an information center, there's a site fidelity. So how would you know where to come? How would you know where to get the information? So there has to be a particular site. So so all the birds come to a single site. It doesn't matter who ate or who didn't. They'll all come back to the same site. So they'll know that, okay, probably I didn't eat today, so I might get the information to eat the next day. So that's one. Then synchronous departure. Basically, okay, you guys must actually have you do you guys know of where to find a roost of of crows, like house crows or large bill crows. Basically large bill crows is
No.
you
It
if
happens a lot in near my home.
yeah,
So
yeah, if you spend a little more time in the on the roofs and see carefully, you'll see that all the crows in the evening are coming back. Actually, you can do that right, no, not anymore, but all the crows are coming back, and they are coming back from one particular direction. uh, you must do that. I mean, I've seen it in
yes,
like
sir,
last.
actually, I have seen this today
Yeah.
itself. I saw it not only to roost, but in the morning when I was birding for the GBBC. There in the morning also, I saw a group of around 20 to 25 house crows. They just flew from one direction and they sat in the same tree.
Hmm.
They were coming and going and coming and going, but they were all together in the tree for a long time, cawing, cawing, cawing. Slowly they dispersed. But
Okay.
whenever they assembled again, they assembled in the same tree. Whenever they assembled in the same tree the whole day.
Okay.
It was like,
So I'm not talking about that. I mean, that is probably after they disperse. So I'm talking about like group. When I say group, like there might be hundreds and 500s, but they don't come together. They come in like a smaller troops of 2 or 3, 4. So it's spaced apart. So people, I mean, people generally looking at it would see that there are only 4 birds, 4 crows coming to the side and 5 crows coming to the side. But if you sit and wait and see, then you will find that from the same direction there have been like multiple sets of birds like this that are coming from the same direction. So if you count them, there would be like 500 or 400 birds altogether. So I understand what I'm trying to say, right? So that is probably, I mean, and if you get to know where these birds are roosting, you can go and check. I mean, for me, when I was studying them, I had to go early in the morning, sometime like 4 o'clock or 5 o'clock or something. That's when, till then the birds would be there on the tree, but with the first hint of light, there would be like 1 or 2 birds which immediately go start flying and going to one direction, and then you'll find that the 3, 4 birds may make smaller groups and follow the leader. So that's basically the third option, following.
Do egrets
Also do
or
that, yes.
okay?
Also do that. There are a lot of, yeah, egrets, vultures, crows, all the birds that roost, even harriers, for example, they all roost, and they all might have this information center these hypothesis. You must look into what are the reasons why birds roost. There are several hypotheses. Information center hypothesis is one. Then there are like many eyes hypothesis, which is the other. So basically, that would mean that as a group, they will be able to avoid predators better because there are many eyes to look around and inform if the predators are nearby. So that's one of the hypotheses. Each of them have been proved, disproved several times. None of the birds sit very perfectly, or like none of these events sit very perfectly with one particular hypothesis. But I mean, one must be aware of these hypotheses just so that, yeah, just for the sake of it.
I have a question or some point related to the graph that we had earlier about information center hypothesis. When two birds are uninformed and the food is not present, and I was expecting that both of them are hungry, want to do foraging, but because they are not individually, there'll be lesser success. So why can't their flight be for a longer duration together, like a flock, so that they can increase the chances of food? I mean, that will be actually wrong, increasing the chances of finding the food, but staying together can get them fed together. So I was expecting that they will fly together for longer time and then continue, but that doesn't explain from the graph. So what
Yeah.
could have been the reason for that?
I think I can. This only, right? Time proportion of joint flight.
Yeah, the first part itself, too uninformed and food is absent. So they may go both together, try finding the food
Or would
together.
it be
So,
better if
huh,
they go apart and try finding food better? Would the chances of finding food would increase that way? Don't you think so?
yeah. So that was another thought came to my mind that going in other different directions will increase the chances.
Yeah. Basically, the point of this whole this is like experiments like this has been done throughout. I don't think, yes, yeah, the faculty is introducing you to a lot of experiments that have been done, but kind of experiments that, to the extent people have thought about these things, is like, I was just amazed that people and birds, like how much people have thought how birds behave and stuff like that. So, yeah.
Hmm. Thank
But
you.
anyways, I've given the paper. It's there, right, Harold? So probably you can go through it and,
Yes, yes.
yeah, and probably explain to us the next time. But anyway, the answer over here is all of the above. There are 5 more. If you want to, you can read the paper. The name is there on the screen.
So this hypothesis would mean that birds are very social, right, sir?
Hypothesis would mean what?
That birds are very social.
Yeah, this hypothesis fits well for social birds. Information center theory is for birds that come together, socialize together, brood. Sorry, what is it called? Roost together. Okay, so there are 3 people who answered. Yes, Harsha. Yes, Harsha, you want to say something?
Hello.
Yeah.
Yeah. Hello.
Yeah, go ahead.
Yeah. What does it mean by means of higher and bigger, as in size of the food, or in higher as in?
Higher is like greater amount. Just think of that.
Okay. Fine. Thank you.
So, yes, Govind.
Well, sir, I would think that it would make more sense for the bird to take food back home when the plate is closer, right, sir? So, since if the plate is further away, it'll cost more energy to bring the food back, so it's better to eat there.
Oh,
No, but what about feeding the
yeah,
chicks?
feeding the chicks. But everyone understood the question, right?
The same, I think, earlier question about energy versus handling time principle.
Yeah, it's the same thing. All right.
Sir, so how does option A make sense
Oh,
in the previous question?
so yeah. So suppose the bird has to feed chick, then and it has to bring the food. I mean, so it was trained basically to feed only from one plate and vary the time of dropping leather jackets on plates. So when he varied the distance of the plate from the nest 8 meter to 600 meter and averaged the effort every day, he found that the bird took less food back home when the plate was closer, but more when it was far. So there is some training happening. So basically it has to bring the food and then eat to the plate and eat. So it makes sense because the amount the the energy of the food and the handling time. So over here the energy of the food is you guys should look at the yeah, just a sec. I'll so yeah, this is so over here. No. Okay, so over here, everything before before that T2 line, right? Everything before the T2 line is the handling. No, sorry. Everything before the curve starts happening. You guys saw this graph, right?
Yes, sir. We saw this graph.
This is the gain curve.
Yes, sir.
That graph that Moshimi was talking about, and you see where the short search time is, and you see the curve coming from 0 to up energy gain, right? So before that everything is search time, and after that is the time feeding. So over here, the search time for the bird is less when the plate is closer. The energy gain is less as well. So it doesn't. I mean, it knows that the search time is less, so it'll bring smaller amount of food because it doesn't have to spend that much time to look for the food. But when the distance increases, the search time also increases. So now it knows that it has to take more food because the search time has increased. So yeah, so T1 and T2. I mean the so yeah, I mean there's another graph that I was yes. Okay, so I can share you this this PDF if you want. This is from a book, but I can share this. Let me see if I can get hold of this. Um, just a second. I did find something. Yeah, yeah. I can't send a PDF over here, right? Or can I? I can't. Okay, anyways, the PDF looks like this. I don't know how to send it to you. Send link? No, it's a PDF. It's basically
Is it possible to send on the Google group?
I'll do one thing. I can share you the name of the book. So probably if you can find a book, then it would be easier. Uh, the name of the book is okay. Wow, I think I got this PDF from a very long time, but the name of the chapter is Economic Decisions and the Individual. Probably you can find it. Economic Decisions and the Individual. And the author is something I'm not very sure who the author is right now. Let me see if I can see the. Actually, no. I mean, just do one thing. Alex Kastelnik, 1984. That's the name of. I mean, it's Alex Kastelnik, 1984. So look for his paper. The paper name is not Economic Decision and the Individual, but just look for Alex Kastelnik's 1984 paper. You'll find this experiment a little more in detail and what kind of experiment he has done and everything. So. Yeah. Are the others not understanding that? Yeah, so everyone understood what it is. It's called kleptoparasitism. Klepto is basically where klepto is the I think Greek or Latin word for stealing. That's also what's kleptomania and people who have the habit of stealing. So that's where the word the root of the word is from, and parasitism is basically parasitism. So yeah, and have people seen this behavior anywhere?
In bears do that too.
In what?
No, I have seen this in kleptoparasitism. I have seen in the drongos itself, sir. The black drongo itself. There is this marshland near my home, which used to be a patch for me. Now the access is cut, but when I go there, at least once in the week, I go there 4 times a day, week, and once at least I get to see it giving false calls. It what to say? It mimics the bee eaters, and it mimics bee eaters call, and the bee eaters like they all huddle together and they fly away, and whatever the one bee eater had it in mouth, it falls down, and this drongo swoops down, and before it touches the ground, it catches in the beak and it goes back to its perch.
Oh,
This
so
I have
you're
seen.
basically saying that the bee eater caught something and
Yeah.
oh, that's interesting. I didn't know that.
Yeah, I when I was studying, I was intrigued with this, and then I searched to Google, and then I came to know about kleptoparasitism. So I could relate to that theoretical knowledge with this practical knowledge. I don't know if bee eaters have any kind of interaction with the drongos or not, but this is what I saw happening in front of me in that marshland, and I thought, okay, I might be seeing things because it was a sunny time. It happened again after a few days. Again it happened, wherein one other bee eater was having a dragonfly in its mouth, and it fell down, and this swooped and took it.
But why did it how did it fell down? Like
That same thing, it called, it gave an alarm call. It was not the normal drongoish call. I think it's a mimicry call only, and it gave a call, and suddenly these 4 or 5 bee eaters which were perched on the electric line, they flew off, and then they flew to a distance, and then they came back again. Okay, when they flew off, this bee eater's mouth, whatever it had, it fell down, and before it touched the ground, Drongo caught it.
okay, that's interesting because let's see the next question now. Yeah. Oh, okay.
Sir, just 1 second. In the
No.
previous question.
Yeah, the previous question
wha-
would be explained in the 16th question, but yeah, go ahead.
Well, I have no doubt in the previous question, sir. I completely understand it. It's just option A and D. I would like to know more about them.
No, that's I'm making up stuff here. There is nothing
Oh,
called stealth.
okay. I
surgery.
just wanted to know that.
Yeah, that and cryptoparasitism.
There's
is
no
also-
such thing as
No. I was just making stuff up.
I guess you're good at making options, sir.
No, I'm not. But yeah. But you actually thought okay. But anyway, so apart from
Well, I had my doubts.
apart from Lakshmi, did anyone know what kleptoparasitism was? Have they heard of this?
No, it was during the
I
lecture.
know, sir. I knew.
Okay.
I saw it in a documentary once, sir, about
yeah.
bears actually.
Yeah.
Apparently, in Yellowstone, wolves would catch elk or moose, and then a bear would come and chase them away.
Oh. Okay. Yeah. It happens in.
Apparently, bears follow wolf packs in order to get food.
Oh.
Will that be called kleptoparasitism? I mean to say, whether kleptoparasitism involve only making a false alarm kind of thing, or is it just shooing away the owner or the host of the food?
No, actually, it's stealing the food. So basically, not hunting and stealing the food. So
So
it's
in
there.
any way,
It's yeah.
in,
It's there. There's a paper where they have studied kleptoparasitism in gulls, where there is no communication of any sort of like that. It's just stealing. Gulls or petrels. I forgot one of the
Petrels, sir.
petrels.
Storm
Petrels.
petrels.
Storm petrels. Yes.
And skuas also.
Yeah, yeah. So they all do that. So basically, it's stealing and doesn't have
Jaegers,
to.
Jaegers and skuas and yeah.
Yeah, it doesn't have to have this
And
whole acoustic
frigate birds also, sir.
frigates. Yeah. Oh, frigates do that very well. Yes.
Frigates can't get their feathers wet, so instead they steal it from other seabirds.
Yes, that is there in one of the documentaries that I saw. Yes. Anyways, so the next.
So basically both are same, no, sir. A and B are both are same. They are just worded differently.
You sure?
No, sir. In A, different species deliberately come together and form a group. In B, it's just they just happen to be together in a resource-rich area.
Nothing happens to be, no, sir. In nature, nothing just happens to be, right? Everything has a
there'll be
deliberation.
initiator. Yeah, so there'll be initiator in the first case. The A case, there'll be initiator like a drong or something who will make calls, and the other may just follow them. They're there.
So you say that A has a leader and a follower, and B is just a group of herd of
yeah.
sheep.
Yeah. So, for example, like seagulls on a sea beach, that's not a mixed species flock. I mean, there are different kinds of gulls, but they are all there for the high food availability on the beach.
Like the waders, you know, all the waders they together they forage mixed flocks only. We see waders and mixed flocks only.
Yeah, because there is no interaction as such between the species. But okay, let's just. So, what's the answer over here? People think.
A, sir.
A. Okay. Oh, Lakshmi thinks it's B. I think it's A. But let's just move on to the next question. Here. Actually, mixed species flock would be taken further up by another person in the future lectures. So, just. But because we are also doing foraging, so I thought I'd just bring that up. Yes, Ruth Bates perfectly makes sense. Yes, Lakshmi, go ahead.
Sir, what does exactly mean stimulate, sir? Like, what actually stimulates the formation of a mixed species flock? It's like how can one species can stimulate the other species or the other species around them? Like, how do that stimulation part work?
I'm not sure, but have you seen a mixed species flock,
Yes,
Lakshmi?
sir.
You have.
Yes, sir.
So what happens in a mixed species flock?
All I have seen is recent of late. I have seen as I was doing Asian water bird census, so I have seen only waders. I don't see any kind of interaction between different species, sir. They are keeping to themselves and they are foraging. They are just sharing the territory with all. The territories are overlapping, and the food they have it. They are peacefully coexisting and having the food. It's not like somebody is leading and somebody else is following. I don't see that kind of strategy anywhere, sir.
So
So
is
I'm
that a
asking.
mixed species for flock, or it's just a congregation of several species of birds? With,
I felt congregation, sir. It was
Okay.
not.
But has
I,
anyone seen a group of babblers and drongos, like a lot of woodland birds basically? People must have seen mixed species flock, right? I mean, most of you are birders. I suppose.
yeah, I have seen only but I have not been to woodland areas much. I have only birded in wetlands and also in urban area, but I haven't seen babblers interacting with others and peacefully coexisting with other. I have seen only babblers. They are like 4 or 5 babblers together. They forage together, they call together, they fly together, all those stuff. But I haven't seen any mixture of it. That's why lack of experience only I'm asking, sir, because I'm not able to imagine the options in my mind, so that to come in, know which one is the correct answer.
Okay, what did people say
I
the
have
answer?
not.
Yeah.
I have not seen the. I mean, I have seen the flock, mixed species flock together, like in the area of Tatekad bird sanctuary.
Huh.
But at that time, I was not aware of this characteristic of the like the flock was consisting of racket-tailed drongo and maybe ruby-throated bulbul or something like that. But I was not aware of this theory. So after going through that mimicry and I mean voice mimicry and other lectures, I felt it might be the one of the examples of that, wherein the racket-tailed drongo might invite others or basically make a false call and they join, and then all of them may have food together, and also racket and drongo might extract something more out of it.
Okay. Yeah. So basically, okay. Well, let's just come to the answer first, and then we can. Okay. So why is this the answer first? So nuclear species is the species that's the. I mean, it's one of the theories. I don't know if it fits well now. Like this was some 10 years back. There was the distinction between the species of mixed species flocks, the mixed species MSF or whatever, and nuclear species was one of the term given to the major species that are actually uh, responsible for a mixed species to stay together. So first is to simulate the formation of a mixed species flock. Okay, so how does that happen? So why do mixed species flock form? So basically, there is one species that is like the hard worker, and it so say suppose a babbler. The babbler are 7 or 8 on the ground. They would keep turning the leaves upside down. I mean, basically doing that work where they are basically sifting through the leaves, and in that process they are upsetting a lot of insects that are flying into the air, right? You guys got it?
Yeah.
Yeah. So in that process, while they're upsetting those leaves, they are also bringing the insect into the air, and that insect in the air is being eaten by other birds, right?
But does it mean that the babblers were actually not looking for the insects?
No, they are looking for the insect, but they are looking for the insects for themselves.
Yeah. So you mean to say that some flew away, which
Yeah.
were caught by others? Okay.
Yes, and
Sir,
similarly, not
yeah.
just babblers. I mean, I suppose there are other mixed species flocks where the babblers are not involved, where the birds are pecking on the barks of the tree, and there they might be. So it all has to depend on the group, like how big the group is. The bigger the group is, the probability of other birds getting food would be more, right?
Sir, does the example of cattle aggregate and cattle come under this? Like the cattle is foraging, and it is when it is walking, it is picking up the dust, and it through its hoof, it is turning the dry sand or mud or whatever. And the cattle aggregates behind, they follow these cattle and they catch the worms which has been turned up. So does this also come under
I
mixed
don't.
species foraging?
Yeah, I know. It's very tempting to call it that, but I don't think so. I think mixed species flock is only for birds. Uh, but as far as I understand, squirrels and birds also form mixed species flock.
Exactly. That's what I was about to ask.
Yeah.
If it isn't cattle, then if it is squirrel, because squirrels are known to give for alarms whenever there is some raptors around.
Yes.
So
Yeah.
does that mean it has to be avian species, or it can be mixed species in a true sense?
Yeah, I think so. I think so. It's very tempting to call a cattle and cattle egret combined together in mixed species, but I'm not very sure if that would be called a mixed species flock. But yeah, I mean there would be experts to call upon. I mean obviously there's one more. There's somebody called Preeti Bangal who might teach you, whose lecture might be there in the future. Yes, Govind, you were saying something.
Yes, sir. In the example you gave, babblers disturb insects in the undergrowth, and say drongos, they catch the insects that fly into the air, right, sir?
Yeah.
In such a case, are they working together, or are they just happen to be together?
Okay, so there is one kind of species called nuclear species. There's other kind of species that is. What do you think the other kind of species is called? What do you think the drongo would be useful for?
Um, Alarm calls, as it was mentioned.
Yes.
Symbiotic relationship.
Yes. So that's the alarm calls. They are basically called. Uh, okay. Let's. So they're basically called the sentinel species. So there's a nuclear species which are okay. So why was the option B not true? Can somebody tell me why the option B was not true?
If
They are being social,
the
right?
non-social birds, if they are non-social,
Yeah.
they would be hostile to each other in the worst part, or they won't what to say, gel together and form a working flock.
Yes, the flock is
There
important
has to be some
because more.
mechanism to keep it oiling.
Yeah.
There has to be some mechanism to keep it working.
Yeah, and the flock is important because more the birds are together, more the probability of the insects in the air because of the movement of the birds below. So there would be, yeah, more beneficial for other birds in the air, like the sentinels and the other birds. So yeah, but yeah, it's interesting if you.
So the
Yeah, go ahead.
Sir, so the nuclear species cannot be non-social. Is that what you're trying to say, sir?
Yeah, it should not be, technically not be non-social. Yeah. I mean, this so everyone must be knowing what the answer is by now. Nuclear species is not non-social.
So, if I understand the term nuclear species, it means that it is kind of it looks for its own food. It is looking its own food, irrespective of who else others are getting fed. But in the process of searching for its food, it unknowingly or unintentionally, it is helping others. That's the nuclear species, no, sir.
Yes, yes, yes.
Then it has to be babblers only, no, sir, because they are like, as you said in the previous example, they turn the leaves and do a lot of foraging part, wherein they release the hidden insects or something for the other species coming behind them or foraging next to them. But they doesn't exactly mean that they are extra helpful and they are calling everybody, come here, there's food, come and eat. They are not doing that. They are foraging for themselves, and meanwhile they are also helping others. So I would guess babblers are the correct answer.
Yes, I think so too. So drongos are what we call the sentinel species. The next.
Sir, so nuclear species are the ones that bring together the group.
Yeah. But they also the one that are social, and they also the one that are what was it? Generalists that employ a gleaning foraging strategy. The gleaning part is important over here, right? Gleaning is basically
They look through the undergrowth.
yes. So that's the important part over here. So they are the ones. I mean, they form the. I mean, they are the ones stimulating the formation of mixed species flock, because they have this whole foraging strategy. A lot of birds together feeding in the ground or on the bark of the tree, and disturbing the insects that fly in the air, and then I mean, helping out the other birds. So yeah, so that's why it's babblers, the nuclear species. And the last question for today is again drongo. Their role is to alert the other the birds in the mixed species flock to the arrival of the potential predator. So the example is, yeah.
Sir, so in the case of the squirrel-based example you gave, the squirrels are a sentinel species.
Not exactly. I mean, they do give off alarm call, but I think they. So look at it this way: sentinel species are also situated at a higher ground. Do you get my point over here?
If I understand what you're trying to say, it means that when the babblers, when they turn the leaves and the understory vegetation, and the insects are released and they are flying high, the higher when it flies high, then the drongos will come and swoops it. So like that.
No. So what I'm trying to say is, okay. Also, there are mixed species. Sorry, mixed species flock can be like extremely different species also. Like for example, the langus and the cheetahs in the forest, they also form mixed species flock. So the the langus eat the fruit. No, the cheetal graze on the ground, and also eat something. No, for some reason I forgot what the mutualism is here for, but basically langur are on a higher position to be able to see the predators from the ground as well as from the air. So they are able to give an alarm call at the right time, so that the cheetal are also alerted. The same over here in drongos and babbler example. The alarm call giver has to be on a higher position to be able to see the predators. The animals that are on the ground, basically the squirrels and the babblers, both they are not at a vantage point to be able to see the predators coming, and that's why they cannot be the sentinel species over here, is my point.
Still feel that the nuclear species is drongo, which is driving or congregating the other species. So I think we need to look into this aspect.
Possibly.
I may be wrong, but I just searched for that, and one of the article was mentioning that there are other interesting aspects of mixed species flock. For instance, some species appear to take the lead in forming the flock to serve as nuclear or core species. So, and the drongo fits into this category. That's what they're mentioning. So
no, actually, drongo doesn't fit, Sachinji. Like, see, yeah, they are sentinel species. They help in the protection of the whole flock. But in first of all, think like this: they are flocking together. They are moving together in search of food, right? So babblers are the one, like hypothetically, I'm saying babblers are the one who actually are helping the other organisms, other birds around them to exploit the habitat. So somebody is keeping an eye over them is also like keeping their eye on themselves also. They have to also be safe from the predators. Like, see, drongos are also themselves prey, right? So they are not only helping others, but they are also helping themselves by being alert.
No,
So, but
no, but
the organisms which are the birds which are alerting others, they can't make the group. I
no, no.
think.
That's what I'm trying to say. In this particular case, where mixed species foraging flock is done, so
Yeah.
drongo is actually doing a voice mimicry, attracting other species to that foraging area. Okay, so that maybe, for example, babbler, they will try to forage, maybe the disturb the leaves and disturb the insects. Okay, so drongo in a way doing two activities. One is they are attracting other species to that area to
No.
find out more food. One
No,
part sick.
I think you are getting it wrong, I guess. See,
No, no, no. Actually,
drongos mimic the birds just to get the steal their food, right? Here, kleptoparasitams can also come, right? They can
True,
mimic the
true.
birds,
Why
not
are
to call them,
that's why
but
they are calling
to
others.
scare them away also.
No, no, that's
That,
because of kleptoparasitism, they are trying to attract other birds so that they get easily the food. So the energy spent for handling the food is lesser for them.
how mimicking the same bird will attract the birds? Like
Oh,
how? I
okay.
mean,
So
I'm
they
not
will
understanding
do
what you're trying to
they
say.
okay. So what they do is they will try to do the species call, for example, babbler call or maybe the woodpecker call. And what will happen is that it will be similar to other woodpecker. So other woodpecker will be attracted to that site, saying that okay, there is another of the same species there, maybe because of food. So there are two types of calls which is highlighted in the voice mimicry lecture. I think Moshmi
Yeah.
ma'am.
So what
So
does it
so
serve the purpose if another woodpecker comes there? At the end of the day, the drongo has to get the food, right?
he'll get it because he will try to again shoo away sometimes by doing another predator call or something like
No,
that.
see, they are not obligate kleptoparasites, parasites, right? They are applying the.
Okay. Lakshmi and Sachin, it's a nice discussion, but we are over time, and I think we'll have this mixed species thing again in the future. If you haven't had it, I don't think you have had it. Preeti Bangal's class, which is already recorded, would be either presented to you or maybe she will be there in person.
Oh,
Yes, Govind. And you're right,
I just
Sachin.
checked up in Google.
Govind, just a sec. Sachin, you're right. This whole nuclear and sentinel species is actually an outdated. It's not outdated, but it's kind of an old new nomenclature, and people don't know exactly which is nuclear and which is sentinel. And which, sentinel is easy to say, but which is nuclear anymore. So probably Sachin is also right, but yeah, go ahead, Govind.
I was just about to say, sir, I too remember from I attended the course last year too, and I seem to recall drongos also being called nuclear species. So I just googled it now, and I read that in a short article that drongos in some cases can also be considered nuclear species in mixed species flock.
Yeah. So
So in a way, yeah, drongos are also nuclear species, at least in some cases.
yeah, I mean,
I think it comes down to who forms the group, sir.
yeah, but who I mean, yeah. So yeah. Anyway, so the point is you would get to know more about this in the future class. So yeah, that was my last question, anyways. So yeah, cool.
Thank you, sir, for
All right.
informative and interesting sessions. Sir. Thanks a lot.
Thank you. I hope you.
Okay.
Thank you, sir,
Right.
for the discussions.
Yeah. All right. Bye. Good night.
Sir, Jobin, just one query. I had a question about exam. So, is there a way I can connect with someone from NPTEL for exam related query?
Yes, there is, right? I mean, NPTEL has or you can, what you can do is you can just post your question in discussion forum. It usually is taken by Devika, or she usually passes that question to the exam people.
Okay, yeah, thank you. I had actually replied to the email that I have got from confirmation about the exam And also copied one of the email of NPTEL. I think the exam at nptel.org or something that bounced back. But
Okay.
anyway, I'll post it on the group.
Yes,
See.
yes, please do that. Okay.
Thanks.
Sure. Okay. Bye. Good night.